Hello and welcome. This is Safa. In this video, we'll simplify the AUV dynamic model and represent it in the state space from a chaos step toward control design. Real AUV models are nonlinear, coupled and very complex. Designing controllers for them is hard. That's why we use simplified models good enough for control and easier to analyze. Previously, we looked at the full dynamic model of an AUV. It includes mass, correlates, effect, damping, and restoring forces. It's realistic, but too complex for control design, so now we simplify it. This is the state space representation, standard form used in control systems. It related the system states X, the inputs U, and the outputs Y. The matrices A, B, C, and D describe how the system behaves. To simplify the model, we assume 3 degrees of freedom, surge, sway, and U. In a horizontal plane, we ignore vertical motion, correlates forces, and non-linear. This lets us build linear model suitable for basic control. Here's a basic linear model matrix. A defines how the vehicle's motion evolves. It includes damping and slide coupling. Matrix B shows that each control input directly affects its corresponding axis. Okay, let's go to MATLAB. Okay. In MATLAB, we define the A and B matrix. And simulate the system response to a constant input. This gives us an idea of how each velocity changes over time. Okay, matrix A, B, C, D. Plot. Okay, we now have a working simplified model of our AUV. In the next video, we'll begin designing a sliding merge controller based on this model. Thanks for watching. This is Safa. We're learning together, one concept, one line of code at a time.